Welcome to Absolute Values and Radicals for Pre-Calculus Math 11. Today we're going to be taking a look at solving radical equations, section 2.5. When we solve a radical equation, we can follow a few steps that are common with basic algebraic equations. And in basic algebra, what we do is we just try and isolate for the variable. For example, when we solve 5x minus 3 equals 12, we isolate the variable by performing inverse operations. So it's the operations that really cancel out what's around the x. So if we have 5x minus 3, adding 3 is the inverse operation of subtracting 3. Division by 5 is the inverse operation of multiplying by 5. So for solving radical equations, we need an inverse operations for square root, or cube root, or fourth root, or fifth root. And this inverse operation is squaring, or the square. So solving radical equations follows a few pretty simple steps. Really, it's based very similar to basic algebra where we isolate. Identify any restrictions. Because we're dealing with radicals, remember that we can't take the square root of a negative number, can't take the fourth root, the sixth root of negative numbers. We want to deal with those. The first step really is to isolate the radical on one side. If we have to gather like terms, if we have to use basic algebra, that's what we're going to do. We then square each side, solve for the variable, and check. Now, checking your answer against the restrictions determined in the first step is the important part here. If the answer works, then it is known as a root of the equation. If the answer does not work, then it is known as an extraneous root. Extraneous root. So really, a root is an answer that works when we plug it back in. Extraneous root does not work. So, pretty straightforward step-by-step process. Let's take a look what we can do here. So solve each equation. Let's talk about restrictions first. Well, the restriction for radicals for a square root is that whatever's underneath the radical sign, the radicand, must be greater than or equal to 0. So there's our first restriction. If we try and isolate for x, we start pushing stuff away. Division by 4 would be the first step. So root x equals 5/4. If we then square both sides, we should be able to reverse the square rooting process. So x would then be 25/16. So what we need to do is we need to check this. I think first of all, let's check, is 25/16 greater than or equal to 0? Because that was our restriction from the radical. Sure is. That's a positive number. The next thing you could do is just actually check by plugging it in to the equation. Is 4 times the root of 25/16 equal to 5? And I'll let you do that, check on your own. You'll notice that once you simplify the left-hand side, it does work out. Why don't you go ahead and try example 2. Start with the restriction on the radical and go from there. So, we need that the radicand, which is x minus 3, needs to be bigger than or equal to 0. Adding 3 to both sides, we get that the radicand must be greater than, or the variable x must be bigger than 3. Let's solve. Algebra, what's furthest away basically is adding 6 to both sides, then dividing by 3, certainly then squaring. We have x minus 3, 7 squared is 49. Adding 3, we get 52-ish. So, we have 52 as an answer. Let's check again. Check left side versus right side, but certainly let's check, is x equals 52 greater than or equal to 3? And yes, that is. We can check in the actual equation, just as an especially good check, and see, does the left-hand side equal 15? And again, I'll let you do that for you to figure it out. Let's take a look at a little bit more complex ones. In question C, we have multiple radicals in there. We have a root x and a root x a couple of times. Let's take a look at the first one. Root x has to be bigger than 0. That's from the 4 times root x one. Let's check again. This radical also has to be bigger than 0. Fortunately, it's the same restriction. That doesn't matter too much. In this type of question, when we have the same radical twice, what we want to do is pretty well just gather like terms. So let me actually rewrite it first of all. And let's subtract 1 from both sides. So we get 5 root x on the right-hand side by itself. Let's subtract 4 root 3. So 5 root x. I'm sorry, that's not 4. It should be 4 root x. So 5 root x minus 4 root x. We're trying to group like terms. So that would be 2 is root x. And we're going to square both sides as the inverse operation of square root. And we end up with 4 equals x. So again, let's check against our restrictions. Is 4 bigger than or equal to 0, which was the restriction from the radicals? Sure is. And let's check if 4 root 4 plus 3 is equal to 5 root 4 plus 1, and I'll allow you to do that calculation on your own, figure it out if it's correct. Finally, this is where we get interesting here on example D. Why don't you hit pause for a second and see if you can solve that. So let's take a look. We have that the radicand on the left-hand side, which is x minus 1, must be greater than or equal to 0. So that is x has to be larger than 1. The radicand on the right-hand side is 2x plus 3 has to be greater than or equal to 0. And we get negative 3 halves. That x has to be greater than or equal to negative 3 halves. One way we can figure out which of these two is more restrictive, seeing as they're different, is to plot these on a number line. We see that there's 1, and that we need to be larger than that with a closed dot. There's also negative 3 halves, which is further left. We also need to be larger than that. Now we talk about overlap, or we talk about what's more restrictive. In this case, we get less of the real number set when we say that x has to be larger than 1. So that's the more restrictive restriction. Let's go ahead and solve this. What we can do is we can go ahead and square both sides. So we have root x minus 1 all squared equals root 2x plus 3 all squared. Getting rid of the squares, we get x minus 1 equals 2x plus 3. Subtracting 3, we get x minus 4 is 2x. And subtracting x, we get x equals negative 4. So let's check this versus our is negative 4 larger than or equal to 1? And certainly no is the case here. This doesn't fit into our restriction, so we got an answer of negative 4. The question only worked if x is equal to negative 4, but if we plug negative 4 into the original question, it's not going to work out. So no solution, as x equals negative 4 is an extraneous root. So there's an example of that extraneous root business. This ends the notes for solving radical equations for section 2.5.